Hello, this is Professor Urbis White. Today we will look at parametric equations, and this is part of the trigonometry class, so it's going to have some trigonometry formulas associated with it and how you deal with parametric equations in general. So this is an introductory video, so we are going to look at how we can draw parametric equations and how we can go between, how we can write a parametric equation in terms of Cartesian coordinates. Okay, so let's get started. Now, what we are going to start with, in a Cartesian coordinate system, you're going to have an x and y coordinate, and a point in there is going to have x and y coordinates. Now what we're going to do, we are going to assign x as f of t, some function of t, and then y, some function of t, g of t. So we can write, instead of x and y, we are going to write everything in terms of t. For example, if somebody says, here's your x, and it is, since we are doing the trigonometric one, these are going to be trigonometric functions. Y equals cosine of 2t. Alright, and then we want t to be between 0 and pi. Okay, so what you do when somebody is asking you to do this kind of problem, all you have to do is just make a little table. And you're going to put your t in there, and you're going to put your x and a y. And let's put some values. 0, pi over 4, pi over 2, 3 pi over 4, and pi, because that is the interval that we want to find things out. All you have to do, for example, I'll do the first one. You're going to get sine of 2 times 0, and that happens to be 0. And this one is cosine of 2 times 0, and that happens to be 1. And then you do the same thing. Sine of 2 times pi over 4, and that happens to be 1. Cosine of 2 times pi over 4, and that happens to be 0. So I have a 0, 1. And that's where I start, and I go to 1, 0, that's the next, at t equals pi over 4, and I keep on doing the same kind of thing. Sine of 2 times pi over 2, and that happens to be 0. Cosine of 2 times pi over 2, that happens to be negative 1. And then I have 3 pi over 2, sine of 3 pi over 4, so that's 3 pi over 2. That is negative 1. Cosine of 3 pi over 2, that is 0. So I go 1, 0, and then I'm going to go to 0, negative 1. And then the last one, I'm going to go negative 1, 0. And let's do that, sine of 2 pi, and then cosine of 2 pi. And that one is 0, 1. Okay, where I started. So let's draw these things, and you just take these points, and you just plot them. Okay, where do I start? So let's call this point 1, point 2, point 3, point 4, point 5. Okay, so point 1 is going to be, if I have it 1, 2, 3 that way, negative 1, 2, negative, and 1, 2, 3 here, negative 1, negative 2, negative 3. So this is my x, and this is my y. All I have to do is just plot those ordered points. 0, 1, that's point 1. And then I go to 1, 0. That's point 2, and I go to 0, negative 1, that's point 3, and then I go to negative 1, 0, that's point 4, And then I go to 5. Oh, it looks like I am doing this. So I'm starting in there and I'm going clockwise. Ta-da, and you're done with this, this problem. What you can do in your graphing calculator, like TI-84, you just have to go to mode and then make sure that you set your mode to parametric equations. And then it's going to give you an X and a Y menu, and then you just enter your X and your Y in there in terms as a function of t, and that it will actually graph it after you enter it that way. Okay, so let's do another problem. This problem is going to be, let's say you want to graph x equals 4 cosine t and y equals 5 sine t. With the same token, you just actually, you can make a little bit of a table and then just the same way, and then you can just put in the t values the way you did it before, 0, pi over 4, and so forth, pi over 2. And you can do that. That is one way. Now I'm going to show you another way how you can do this. Now, let's look at the trigonometric identities. So I know that cosine t, when I pull it from this equation, it's going to be x over 4. I know sine t, when I pull it out of this equation, that's going to be y over 5. Now, from Pythagorean identities, I know that sine square plus cosine square is 1. I just know that. So what I'm going to do, I'm going to plug in whatever that is in from here and here. So that's going to give me y squared over 5 squared plus x squared over 4 squared. I get 1. Oh, what does that mean? That means that I have an ellipse, because that is the equation of an ellipse. If you go and review the video for the conic sections, that's the equation of an ellipse. And what does it look like? I know that this is going to be 4, and it's centered at 0, 0, and this is going to be at 5. Very good. And it's going to look something like that. Oops. Let's do this again. Okay, so it's going to be 4 this way and 5 that way. 1, 2, 3, 4, 5. So it's going to be fatter that way. So let's draw it. Okay, now, usually people ask you, so this thing is 5, and it's the major axis, and this thing is 4. Now, people will ask you, which way does this go? So you can just plug in some values. Let's say t of 0. What is x equal to? And x is 4 cosine of 0, and that is going to give you 4. And then when you plug it in, y equals 5 sine 0, and that's going to be 0. So I start at 4, 0. So I start right here. That's my first point. Then go look where your second point is. Maybe you can try t equals pi over 2. And plug that in. You're going to get x equals 0, y equals 5. X equals 0, y equals, so that's my second point. And you can do that. Sorry. Hopefully I didn't lose this. Please. Okay, I think I got it. All right, I just lost the last portion. Let me save it. Okay, so we just talked about this being an ellipse. So let's draw my ellipse. It is 5 that way and 4 this way. And then t equals 0, it was x4. That was when t is 0. And this one was when t equals pi over 2. And that point was 0, 5. So my parametric equation is going this way as time progresses, t being the time. So you can actually use trigonometric identities and draw your parametric equation without putting in values in the table like we did in the first problem. So let's do another one. So we are going to look at another example. Let's say I am doing this problem. X equals cosine of t. Use trigonometric identities. Cosine of t plus 4. Okay, so let's look at this. If my x is cosine t and my y is cosine t plus 4, I can write an equation between x and y without the t's in them. So when you do the substitution of x for cosine t, you get x plus 4. Oh, that's pretty good. And then I can actually draw this. X plus 4 is going to be 1, 2, 3, 4. And then 1 over 1. So it's going to look something like that. Now, if I want to find out which way this we are using, let's think of a little particle or bug just moving along that line. And where does it start? Where does it end? So let's plug in some values. When t is 0, my x, when you plug that in, my x is going to be 1, and then y is going to be 5. Okay? So it starts right here. And then when t is, let's say, pi over 2, a little bit later, my x is going to be 0, and my y is going to be 4. I'm just plugging it into the equation. So this one is that way. So it is starting here, and it's moving this way. And then they will give you maybe an interval where t goes from 0 to some number, and then you can actually see which way that little particle is moving along the line. Now, so that is how you do it given the parametric equation, and you are actually graphing it. So you can do it two ways. Either use trigonometric identities or just plug in numbers and look at what your graph looks like. Now, the next thing is, if they are giving you, this is a little bit harder, if they are giving you the Cartesian equation, let's say something like that, and they want you to write x equals f of t and y equals g of t. And I know that usually from the trig, remember how it was in the unit circle? It was like this. Let's say if I think of this as the angle, and then the radius is 1, and this thing is going to be x and y. Remember? So just kind of do your trigonometric identity. X equals cosine of t, and y equals sine of t. Because adjacent over hypotenuse, hypotenuse being 1, and then opposite over hypotenuse. So I have this, and I can just start with that. If I have an equation like that, instead of x, I can put x equals cosine of t. Okay, I can do that. If that is the case, and look at y. And y has this 4x plus 1 in there, so I can write y as 4 cosine t plus 1. And this is actually the equivalent parametric equation of my Cartesian equation. That wasn't too hard. Let's do something a little bit more difficult. This tablet is acting up. Here's another one. Let's say I have x squared equals 1 minus 4y squared. So let's move things around a little bit. X squared plus 4y squared equals 1. So let's think about that, how that works out. If I put x as cosine t, that is the handiest way of doing it, and you see that there's not a unique way of doing everything, then what would be the y? I know that cosine squared plus sine squared is 1, but the problem is I have this 4 in here. So if I put y as sine t, I'm going to have cosine squared plus 4 sine squared t, and that's not good. But if I take 1/2 of that, and look how it works. This is going to be then cosine squared plus 4 times 1/4 sine squared, and that is actually true. So when I go from Cartesian to parametric version, you don't have a unique answer, because this will work, but so will this one. Let's try it. X equals, instead of cosine t, I can write sine t. Then y is going to be 1/2 cosine t with the same logic. So this is one answer, and this is another answer, and it's not unique. So I showed you how to go and graph those parametric equations. I showed you how to do that in your graphing calculator. And then I showed you how you can take a Cartesian equation, make it parametric, and vice versa.